Hi, I'm Yiling from Peking University. In this presentation, I'm going to talk about our recent work on practical build issue resolution. Build systems automatically transform source code to executable software. It plays an essential role in software development and facilitates developers' build activities. At the same time, build failures occur in a high frequency both in commercial and open source software systems. For example, in Google, build failures for Java and C projects occur at the frequency of 28 and 38%. On Travis, the most popular CI service, nearly 29% of commits are suffering from build failures during CI testing. Definitely, build failures postpone software activities with non-negligible costs. Resolving build issues manually is not an easy task, which is usually quite time-consuming. As reported by previous work, developers often spend hours of time to resolve the build failures. To reduce manual efforts recently, automated build failure resolution techniques are emerging, such as fault localization techniques for makefiles based on dynamic execution trace analysis, and automated build failure repair techniques with search-based strategy. Although promising, existing automated techniques are shown to have limited effectiveness in practice. For example, the state-of-the-art technique can only successfully fix a small ratio of build failures, saying 18%. To provide developers and researchers with practical guidelines on this challenging problem, understanding how build failures are resolved by developers in practice can be helpful. Therefore, in this work, we perform a comprehensive study on practical build issue resolution. In particular, we collect a dataset of over 1,000 Stack Overflow posts related to build issues. Based on that dataset, we further summarize build failure symptoms and fix patterns. We focus our study on the following questions, which we believe could provide insights for both developers and researchers. In the first RQ, we studied frequent topics in how-to questions posted by developers. How-to questions present the knowledge that the developers are inexpert at. They might introduce future build failures, and studying such frequent how-to topics can reveal the difficulties developers face in configuring their builds and the vulnerabilities that deserve attention from automated techniques. In the second RQ, we construct a new taxonomy of build failure symptoms, and in the last one, we summarize the characteristics and commonalities of fixed patterns in each symptom to provide guidelines for both developers and researchers about principal way in build issue resolution. In our study, we construct the dataset in the following steps. First, we use the data from Stack Overflow in July 2008 and December 2019 as a raw dataset. Since SO is one of the most popular community-driven Q&A forum, it can increase the diversity of the dataset. Second, we identify build-related posts according to their SO tags. In this study, we choose three mainstream build tools, Gradle, Ant, and Maven, since they are popular and widely used in previous work. Third, to remove posts with low quality and ambiguity, we further filter the data by only keeping the posts with accepted answers. For the remaining ones, we make a statistical significant sample, ensuring 95% confidence. Finally, we have a dataset of 1,080 posts for the following analysis. Based on the dataset, the manual labeling is conducted following an open coding procedure by multiple authors in this work. Through the preceding process, the posts are labeled with necessary tags for each research question. Now let's move to the results on the first research question. This figure shows the hierarchy how-to topics in build issue with corresponding percentage. From the figure, we can observe a high diversity in how-to topics that developers may ask. Among them, grammar is a topic asked most frequently, such as the usage of the default keywords and the data structure in build script language. Besides, almost 19% of how-to questions are about the difficulties that developers encounter when they try to write build code to implement some common build tasks. The questions vary from naive puzzles to very particular problems. Overall, most questions are about build script programming. It indicates that many developers have difficulties in writing a complete version of build script for their projects. To address this issue, build script code generation or completion tools might be helpful here. As for the symptoms, here is the hierarchical taxonomy of symptom constructed in our study. Nodes are in descending grade level along their depth in hierarchy. Each leaf node represents a category, and its non-white parent node that consists of multiple categories is an inner category. The number in the top right corner is the number of issues in that category. Where in total, our taxonomy consists of 15 inner categories and 50 categories. The broad scope of build error types indicates the prevalence and the diversity of build failures. For time limitation here, I'm going to share some frequent categories, and more details can be found in our paper. For example, parsing is the stage where the build system validates the build script before executing build tasks, and 15% of the build issues occur in the parsing phase. Among them, 59% of parsing issues are illegal symbol errors, which are triggered when the build system fails to resolve characters in the build script. Besides such grammar check, the build system also validates the presence of necessary artifacts such as embedded properties and project models. Parsing errors also happen when the properties and the models are not correctly initialized. As an essential step in build process, dependency resolution stage prepares necessary dependency directly or transitively specified by developers. For example, conflict error is triggered when a project relies on different versions of the same library, and findability errors occurs when the required dependency cannot be found in the specific location. These two common error types cover almost 91% of dependency resolution errors. There is another interesting category of symptoms that do not trigger explicitly during build process, but generate problematic outputs such as compiled class file, assembled jar, or executable application that fails to work properly. For example, there are two common errors: class not found exception or no class definition found error. They occur once JVM is unable to find a particular class at runtime. They are often caused by missing or incorrect dependency in the assemble phase. All Java versions in runtime and compilation phase are inconsistent. Due to their low exposure, this character of issues increase developers' efforts in solving build problems. As for the last RQ of fixed patterns, to capture how developers fix different types of build issues, for each symptom category, we summarize their fixed patterns. We then use this heat map figure to show the frequency of each fixed pattern on each symptom category. Here, x-axis represents different symptom category, and y shows different fixed pattern following their total frequency. Where in each cell, if it is darker, then its frequency is higher. From the figure, we can find that there are prevalent patterns that can fix multiple symptom categories. We found almost 67% of the build issues are fixed by repairing the build script code related to the components, plugin, and dependency. And these build issues cover almost 37 out of 50 symptom categories in our taxonomy. Our suggestion here is to check in plugin settings and instance of dependency declaration first. In particular, it might be helpful to assign high suspicious value to this script code related to plugin and dependency in design for localization techniques, and to add more fixed operations and ingredients on these components in design automated repair techniques. In addition, we also found there exist frequent pairs of patterns and symptom categories. In particular, in the figure, the dark cells also confirm that specific fixed patterns are clustering in different symptom categories. In other words, given a symptom category, most issues in that category can be fixed by a specific patterns. For example, 30 out of 43 illegal symbol issues are resolved by fixing syntax errors. 19 out of 26 conflict errors are fixed by excluding conflict dependency, while 22 out of 44 class loading errors are fixed by adding missing dependency. In spite of such prevalent fixed pattern and frequent pairs, many symptom categories do not have common fixing strategies and they have to be fixed case by case. In particular, the number of fixed patterns in each symptom category varies from 1 to 10, and the average number is 3.08. We also find that almost 79% of build issues are fixed by a few lines of modification on build script code. For example, changing dependency version, correcting plugin option, or correcting plugin version often involve one-line modification. But it's still challenging for developers to transform fixed templates into concrete fixed patching. For example, the assemble phase is interrupted due to the abnormal process abortion in this example. According to developers' discussion in this post, the root cause is a large number of DEX files generated, and setting multiple DEX enable to true can prevent the build process from abortion. Multi-DEX enable is an option in Android plugin, while most questioners are unaware of the functionality of this option. That is, a third-party plugin usually has many options, which requires massive open knowledge for developers to solve such a plugin-related build issue. In addition, we also find that many fixed patterns are non-intuitive for the given symptom category, and the developer often face difficulties in realizing the root cause behind these build issues. For example, the developer complains that the build process is successful, but the generated application does not work properly, and it reports the class loading error. It's quite difficult for developers to realize that the error comes from the building process, because this error triggers after the build with fake successful build status. In this example, the root cause is that the dependency library is not correctly included in the comparison phase, and therefore, to fix this issue, the developers have to add the library back. At last, I'd like to give a quick summary. In this work, we investigate the practical build issue resolution based on SO posts. We first studied the frequent how-to topics, constructed a taxonomy in terms of failure symptoms, and summarized the fixed patterns under each category. Please find more details in our paper if you are interested, and thanks for your attention.